Good morning, everyone, once again, and welcome to this second webinar, REN+HOMES webinar. First of all, let me introduce myself. I'm Federica Fusco. I work for Icons Foundation, and in this case, I collaborate on the REN+HOMES project as Communication and Dissemination Officer. So today I'll be moderating this second project webinar, which, as you can see from the title, will be based on hardware solutions for energy efficient housing. So yes, these bundle of webinars will be all dedicated to opportunities in the building industry. And in this case, we will focus on the hardware. So before starting, really starting the webinars with the presentations from our speakers, just let me give you some basic info about REN+HOMES for those who don't know the project. REN+HOMES is a project funded by the European Union, and its overarching goal is that of optimizing the energy production and consumption of residential buildings. And the goal underneath this is the goal of reducing carbon emissions and addressing resource scarcity and energy poverty. How does REN+HOMES try to achieve these goals? Through the development and application of 23 solutions, which include 9 hardware solutions, 7 software, and 7 circular plus energy homes methodologies. And so the project at the end will develop common methodology that can be applied all over Europe and to different types of buildings. But in this webinar, as I was mentioning, we will focus on the hardware solutions, and in particular, we will see how they are being applied to the 4 demonstrators that are taking part in the project. Because yes, REN+HOMES is not just developing technologies, but it's applying and testing them to 4 buildings across Europe, mainly in Innsbruck, in Austria, La Garriga, Spain, Tallinn, Estonia, and Cluj, in Romania. And so what we will do today is see some of the hardware solutions in each of the 4 demonstrators. So let's talk about the agenda very quickly. The first speaker will be Marichelle Barroso from EvoWall, who will present some of the hardware solutions of the Spanish pilot sites. Then we will have Harald Malzer from Neue Heimat Tirol, which is the lead of the Austrian pilot. Then Julia Prodan from the Technical University of Cluj, who will focus on the Romanian pilot. And last but not least, the 4th pilot will be presented by Catherine Ruben from MATEC, who will present the Estonian pilot and its technologies. And then at the very end of the webinar, we will also have a guest speaker from the Circular Project, who will be Pablo Fernandez, who will contribute by providing further examples of hardware that can be applied to buildings for their energy optimization. Just one last point. Remember that your cameras and microphones will be switched off, but you can use the chat box to pose your questions to the speakers, and you will be able to ask questions at the end of every presentation. Yeah, last but not least, enjoy the webinar, and just remember that it will be recorded and it will be made available on the project social media channels. So let's start with Marichelle. Marichelle, are you here? I cannot see you from my screen. If you're here, please, the floor is yours. If Mary Shell is not here, maybe she's having technical problems, then I think we can start with the second speaker, who is Harald Marza from Neue Heimat Tirol. Please, Harald, welcome.
So, hello, good morning. Yes, I'm in charge of presenting the Austrian demonstration project, which is part of the REN+HOMES project. And yeah, go on. So, who we are, who am I? Neue Heimat Tirol. The name is program. New Homes for Tyrol. Since 1938, we are doing this. And yeah, I'm glad to be able to say we are the most efficient non-profit real estate developer in Europe. What does this mean? Especially in Austria, as you can see here, the left bars are the usual intermediate market prices, and the red bars are ours. So on average, our tenants pay about half the average rent in Tyrol. So you can see about 6 to 7 to 8 euros per square meter and year. That's social housing in Austria. And in 2024, we built 704 new passive house apartments, because we are only building passive house apartments since 2011. Yeah, some more small key figures. We are only active in Tyrol in Austria, active in 123 communities. We are managing about 44,000 units, 22,000 apartments, and more than 7,500 passive house units since 2011. Starting construction last year, 750. New construction volume is about 130 million a year. Also renovation, Enefit renovation, ecological renovations are about 35 million a year. And this all is done by my socially responsible and innovative colleagues. We are about 170, whereas just 35 of us are part of the construction department, like mine. So, first question I ask you, or maybe you will ask, why build energy efficient passive houses, especially as a social housing provider? So, yeah, that's the answer. Just look at the energy heating costs. We starting low energy buildings 1997, started only passive house, started in 2011, and then when you see the blue line, which is the indicator for fossil energy costs, you see we are just going down the last year. So only with a highly energy efficient building standard such as Passive House or Passive House Plus, which is our standard since 2021 now. So in terms of the crisis, and including renewables, only in this case we can cap the energy cost for our tenants as low as possible in future. Yeah, going hand in hand with our growth in PV systems, as you see beyond, at least this year we are reached more than 2,000 kilowatt peak installed on our facilities. Yeah. And therefore, I can say we are the largest non-profit passive house builder in Europe. So, about our project vision, concrete for REN+HOMES. We took one building, you see the red one here in front. The rest of the part we had already done before in Passive House Standard, as I said. And this one is a special student and young living project. And I thought it would be a good idea to use this for building the first renewable energy-based positive home. As you can see, for sure, the renewables will take a big part. And here at the yellow bars on the right side, you see the old problem that we have demand and we have to gain energy. And this is often mismatching. One of our motivations for doing and for investing us in sustainable and energy efficient buildings since decades now, is the change of the climate, as you see on the right below. So we are getting hot and hotter, and the intermediate temperature rise in Tyrol is, maybe you know, the worldwide goal is about 1.5 to 2 degrees plus maximum, and we here in Tyrol have already 4.1 degrees plus already. So we have to meet this challenge. And also one technical part, which is an important one, is the seasonal energy storage. We are realizing within this project, this is done via a hydrogen, seasonal hydrogen storage for electricity. And this all is monitored in detail. It will be also our first passive house premium, because that's it has to be if you want to be really energy plus. So this will be the first passive house premium standard we build. And beside the seasonal storage here on the left side, the renewables on the top and on the facade of our building, there is, you can see on the right top, another important part of lowering the energy demand in our building. This is the drain water heat recovery system, and this is the part of this the technical topic of this presentation. So, as I said, you had to lower the demand of the building, the energy demand, as far as possible to be in any way able to be positive. And the passive house premium standard, by the way, tells you do not have to use more than 30 kilowatt hours per square meter in year on renewable primary energy demand. And on the other side, you have to gain more than 120 kilowatt hours per square meter. So this is that you really and trustful can say you're positive. So you can see this gap is not easy to reach. And one of the technologies we use is the drain water heat recovery on the right side, which is also be part of, be monitored and assisted by the planning by our partner Passive House Institute. In fact, the drain water heat recovery is a simple passive coaxial copper tube, in our case with a length of 2 meters, and it's a quite easy system. The warm drain water shower watering is coming down from top to the bottom, and at the bottom of this tube the cold fresh water is going in the coaxial in the separated chamber, and while going up it is preheated and going directly back to the shower system. So that's as simple as that. But have some look on the numbers. So why you should or could do it. First, this is, by the way, this building simulation tool, the PHPP, the Passive House Planning Package, which is always used in our case of NHT for our buildings. The university is doing a dynamic simulation additionally, and also feeding in the monitoring data later on. So first part is the domestic hot water needs. As I told before, this is some kind of special usage building. It is for the younger people, students, starter apartments, and starting your life. So there will be mostly young people, and they are hopefully more sporty than me. So they are doing showering because, and therefore you can see the showering part is the most usage of the hot water. And this is good because this could be very well combined with the heat recovery. And if you do the planning in the PHP, you choose which system you use and how it is connected to the warm water and the cold water system, and also the pipelines have influence on the overall efficiency of the heat recovery. So in our case, we should gain a bit less than 50% of drain water heat recovery efficiency. This means in total number, without this system, we would have to use about 48,000 kilowatt hours for a heating demand for the hot water. And with the drain water heat recovery system installed, a passive one, by the way, so no extra energy is needed, no pumps or something like that. We should just need 29,000 kilowatt hours, a minus of 20,000 kilowatt hours. So this is a really important part when you want to do a passive house plus building. So excusing the sounds you may hear, because we are expanding our office, and yeah, we're getting bigger and bigger, and so you hear the pneumatic hammers at the very right moment, as always. So here you can see the current planning of the system. It's in the first site, it seems quite difficult or complicated, but as I told before, it's a simple tube at the end, coaxial tube, and the most you can see here are parts of the very comprehensive monitoring system, which is part of our research project and is not the normal thing you would have to do when you want to implement this system. What is always very fun, and I like this, on the right side you see the execution planner. Yeah, so they doing their hand drafts because it is a new system for them, and so for their understanding, they need their own drawings, and I really like that. Looking at the building side, because most of the parts of this heat recovery is already installed in the building. You can see on the left side the fresh water station, the central. Each apartment has this. And you can also see, by the way, the exhaust and fresh air, because for sure, as a passive house building, we have air distribution, ventilation system with heat recovery, a central one with the apartment parts. So yeah, I also want to mention that the University of Innsbruck has done two good papers on the wastewater heat recovery systems. So one they made by themselves, and the second one they provided through the REVA guidebook, which is also assisted by the European Union. So on the left side again, you see the opened freshwater station, which is doing the heating and the warm water in this apartment. And on the top, you see the heat meters, which are again only necessary for our special monitoring within this research project. On the other side, it's just a normal freshwater station. So how does the heat recovery really works? You can see here the head of this coaxial copper tube, and here you can see the cyclone, which is very important, because from up the warm water is coming, and then through the cyclone it is really laying on the side of the copper tube to have the best heat conductive. Yeah, and from the bottom, the cold water is coming in and warms up, preheated, and the blue tube you can see here is going back directly to the shower, because it's a one-to-one action. So when you're showering, within about 10 to 15 seconds, this system is doing the heat recovery and bringing back a preheated normally cold fresh water, which is about 11 to 30 degrees. But in this case, it will be already preheated to 27, 30 degrees, depending on the temperature you're doing your shower. And only the rest from the 27 degrees to your preferred temperature has to be done really from the central heating system. So that's the power of the preheating system. Again, here you can see the overall installation in an apartment. You see the normal hot water pipe coming from the central water, hot water preparation, which is a heat pump, a very efficient heat pump driven by a groundwater well in our case, and the normal cold water well. And here on the side you can see again the heat exchanger. Here the cold water coming in at the bottom, going up, and here at the top, it's going back to the showering. Very important is the quality assurance because the heat pipe, the heat exchanger really has to be installed in the right way, as you can see here, so that the most of the heat conductive and the heat exchange can be assured. The rest is more or less special sensoring stuff I have to show here, which is not part of the usual installation of such a system. But there were several specially designed handmade sensors by the Passive House Institute so that we can really have good results at the end and very exact results at the end, because I told you this is a one-to-one system, so we really have to measure within seconds to really have a reliable monitoring data, and so that we can secure and say, okay, that's the presence of heat exchanger we really achieved, which should be, as you said, as you were able to see before, about 50%. Yeah, again, some tubes and the monitoring lines and the heat meters, very important heat meters in the below the freshwater station itself. So yeah, the overall vision becomes reality. Here you can see the building as it is right now. It will be handed over about January 27. So we have 1 year left, mostly to install the hydrogen, seasonal hydrogen storage, because this is the most tricky and yeah, let me say on the edge part to find the right partners and to do it the best way, because on the other side you can see the renewables are already installed at the roof and also at the facade. On the east, south and west side we have installed PV panels with about 112,000 kilowatt hours a year of production, and yeah, this should be enough to drive the whole building, including the household electrics, so hot water, ventilation, heating, and household electrics to drive it only by renewables. Yeah, we will see. Thank you.
Thank you. Thank you very much, Harald. I find this is very interesting. Also, thanks for providing real pictures of the technology and of the building. Since we are already a bit late on the schedule, maybe I will suggest people to start writing the questions in the Q&A chat. And maybe we can collect these questions and ask you and the next speakers the questions all at once after the next speaker. Okay, if you agree, Harald, maybe you can
from my side,
move.
it's okay.
Okay, perfect. Thanks a lot. And now I think we can move to the Spanish pilot, move back actually to the Spanish pilot. If Marisha managed to join. Are you here? Okay.
Yes. Can you see me now and can you hear me?
Yes, I can hear you and see you very well. So please, the floor is yours.
Okay, can you see my presentation, please?
No, you cannot see.
Yes.
Okay, sorry, because I have some trouble, technical issues and the first time. Okay, so good morning, everybody. Thank you for our colleagues from REN+HOMES for the organization, and above all to all the attendants. First of all, I would to introduce you EvoWall. EvoWall Technology is a company dedicated to industrialized construction. EvoWall Technology have our own construction system in which we manufacture both the panels and the system assemblies, allowing us to deliver fully customized buildings, no matter of their architecture or design. That is why we work from design to reality, because we can make real every project that we design. Within the REN+ project, EvoWorld has designed and constructed a multi-story residential building with 4 floors and a total of 14 apartments. Half of these, that it's 7 units, are participating in the REN+ project. So the building is intended for a private residential use with apartments sold to individual owners, and is located in La Garriga, the north of Barcelona. In the REN+ building, we have introduced different hardware solutions for energy efficient housing based on 4 key pillars. The first pillar is that the entire building has been constructed in compliance with the Passive House standard, as Harald commented before. Therefore, airtightness, thermal insulation, building envelope design, elimination of thermal bridges, and the ventilation system have all been carefully taken into account. Second, the goal was to achieve a positive energy building, meaning a building that generates more energy than it consumes. So to the end, high efficiency aerothermal systems are used for heating and cooling, and electricity is generated through the installation of photovoltaic panels. This is the picture from the roof, the image from the roof. Third, the comfort of the homes is based on bioconstruction, taking into account all aspects related to orientation and the circulation of magnetic and electric fields, etc. And the last but not the least, the reduction of CO2 emissions across the entire process have been taken in account. So industrialization construction already allows better control and traceability, and therefore a reduction in emissions due to lower waste and residual material generation, as well as improved transport optimization. But in the REN+HOMES project, recycled and low emission materials have been incorporated into the panel construction. And in addition, in a house emissions monitoring tool has been developed to track that emissions and the circle life building across all the project. Thus, after completing the full project design with these characteristics, a digital twin has created using VIM tools and Tekla to enable the fabrication of the panels and all the assemblies that make up the system. Some of these aspects will be measured over a definite period of time. Therefore, various sensors have been installed to allow this monitoring without interfering with daily life in the apartments. Some of these aspects will be measured over a defined period of time, as I said. Therefore, as a result, the construction time has been reduced by more than 60% compared to a traditional building. And after 4 months, the apartments will be handed over to their owners. Probably in 15 days, all the apartments can be habitated. So this is because we are talking from design to reality. Thank you, Anna.
Thank you, Marichelle. Also, your pilot is very, very interesting. I find also the application of these technologies and the variety of technologies that can be applied. So I cannot see questions in the chat, but so while maybe someone types questions, I have a question for you. Namely, if you can explain how the hybrid wall contributes to a more sustainable and efficient industrialized construction.
Sorry, can you repeat, Anna? Because I can't hear you very well. Sorry.
Yeah, sorry. I asked you if you can explain how the hybrid wall contributes to more sustainable industrialized construction.
Okay, as EvoWall is an industrialization construction or industrialized system, it means that the traceability is applied in all the process. So we reduce the waste, we reduce the materials that we use to manufacture the panels. Also, we reduce the emissions related to the transport. And also that the construction is very, very fast. When we produce all in our factory, after that, when we go inside in the site that we want to construct, all is very fast, and we don't need to use a lot of energy, a lot of water, or a lot of people working then. So after that, the emissions are very low. And also in the REN+HOME, as I said, we used some recycled materials, focus on an insulated system into the panels. So we reduce also our footprint there. And we also, with iTech, another partner of REN+HOMES, we developed the tool to control all our emissions. So it means that we can apply some process that we are improve.
Okay, thank you very much, Marichelle.
Welcome.
So is there any question from the public? I cannot see, maybe I have problems with the chat.
I can read the question for you.
Oh, thank you.
For the EvoWall presenter, so for Marichelle. You mentioned design was based on magnetic and electric fields. How this affects the energy consumption of the buildings?
No, it means that when we design our projects, we are always taking in account what is the orientation of the building, and it means that when you can switch on or switch off, for example, all the electricity. It means that in the night part of home, in the bedrooms, etc., you can switch off all the magnetics or all the wires, all the electrical, that it means you can rest better, etc. But it doesn't affect about the energy consumption, etc.
Okay.
Thanks, Dimitrios, for the question. I hope we answered your question.
Okay, great. If there are no further questions, I guess we can move to the next presentation, namely that of Julia. So please, Julia, from the Romanian pilot, the floor is yours.
Hello, everyone. Thank you, Federica. Just confirmation, please, if you can see the presentation in presentation mode.
Yeah, I can see it, so I guess
Okay.
everyone can see it.
Perfect. Thank you very much. Hello, everyone. My name is Julia Prodan from Technical University of Cluj-Napoca, Romania. I will present to you today some introductory things, but relevant things, I would say, from the UTC and GeoWall solutions that are developed within REN+HOMES project. Of course, we are, it's not just about me, we are a team here. A lot of my colleagues are also online. And before I move to the actual solution that we have been developing here for several years now, I would like to present to you and give you a little bit of perspective of what type of problems we are targeting with our solutions. And then, of course, from the technical point of view, where is that our solution originates. So first, I would like to just say a few words about the thermal crisis of existing cities of Europe. A discussion that can be very long, but I will try to keep it short, only as an introduction, because it's, of course, a discussion about history, a discussion between the comfort and to what extent our existing cities of Europe, which most of them are very beautiful cities, are really answering the requirements that we have today in terms of energy efficiency, comfort, and also resilience. And we have seen statistics already since several years now, and we know that 97% of the buildings in the EU need to be upgraded. So starting from this, I must say that our solutions at UTCN that we are developing, we are targeting not new buildings, but existing buildings. And there's a significant need in this area to come up with sustainable solutions that can really make a difference in the area of energy efficiency and energy sources. Now, in addition to the, In addition to the energy efficiency, there's also another problem, which is regarding the fact that over 35% of the EU buildings are over 50 years old. Now, some of you that operate already in construction sector, we know that the lifetime of construction, or at least the responsibility that an engineer undertakes for a construction, is 50 years today. So having so much building stock with over 50 years old raises another problem, which is related to the structural integrity and structural health of those buildings. So what we can say about current building stock is that in the majority of it, we are talking about a significant mark of history, but at the same time, we are struggling with resilience and also energy efficiency. So we have seen in the late years a lot of amazing solutions developing. However, some of these solutions are very difficult to integrate in existing building stock. So we need integration, not only addition, and this is what we are trying to base our solutions. So coming to the idea where our technical idea originates, I would like to introduce to you a concept where stability meets sustainability in construction sector, where we would like to take a first focus on structural elements, so stability and resistance, and we are specifically talking about those types of structural elements that interact with the soils. And so the first one that comes to our minds, it's foundations of buildings or underground walls of the buildings, because those are the structural elements that interact with the soil. And we try to imagine that those elements, we try to provide and give also a second role in addition to the stability and resistance, and that's the renewable energy source role. So this is what energy geostructures are, a two-in-one functionality of structural elements of a building. Energy geostructures as a technology in general, it's an innovative part of geothermal, shallow geothermal energy systems. So the systems are actually operating through a heat pump, a soil water heat pump. And this technology is being implemented in new buildings already. And we have also in Romania, we have buildings operating like this, where foundations of the buildings are actually playing the role of ensuring the source for heating and cooling of a building. When we need to do this for a new building, we already know how to do it. Like I said, it's a technology that is being implemented worldwide. However, when we talk about existing buildings, there is challenge there. So this is why we tried to come up with a solution at UTCN to develop some systems that could fit existing buildings and solve the existing problems of building stock of Europe. Now, of course, the system can be implemented in a variety of structures, but the inspiration behind all this is looking at the infrastructure of the building as an energy source. So we tried to fix this missing link, retrofitting existing buildings with energy geostructures. Obviously, we cannot replace the foundations of standing buildings. However, we can achieve the activation of their elements that go in contact with the soil. In our case, we are talking about basement walls. And what we have done, we have used the potential of existing walls of building to transform them through a structural rehab as two-in-one solution into a renewable, local renewable energy source. And this is what GeoWall is. So we are talking about efficiency, but we are also talking about economy and how we can develop the potential of a building that needs retrofitting and rehabilitation and structural rehabilitation, and take its potential to transform its elements into a renewable energy source. What we have done in Cluj, we have actually used a building of Technical University of Cluj-Napoca, a dormitory, a student's dormitory, and transform the existing underground walls of the building through rehabilitation and consolidation at the same time into a renewable energy source. How did we do this? We came up with a system that is composing at the same time reinforcement, thermal isolation, and also an energy system composed of pipes that are later on connected to a heat pump. So all this together in one solution in order to achieve at the same time rehabilitation and consolidation of existing building, but also ensure a new renewable energy source for the existing building. So these are the old plans of the building. The purpose of our pilot site was to generate the energy that we were harvesting through our system, through our GeoWall, to provide the energy for heating and cooling to dormitory rooms to the students. So these are some pictures from the actual execution. Of course, in the pictures, you can see only the outer layer of our system, but like I said, try to imagine it as a sandwich, combining both structural and energy purposes. So what we did, we created also the source, but also we created so we rehabilitated also the rooms in order to ensure the receiver system is compatible with the heat pump system. And currently, as we are speaking, several rooms of the dormitory are receiving the energy for heating and then in the summer for cooling from the GeoWall. Of course, the idea is to develop this further. Also, the idea is to really understand the performance of this system and its potential to be scaled. So that's why our system is has been equipped with a comprehensive and detailed monitoring system to understand its thermal performance, but also thermomechanical performance, because we are talking about the structural element of a building. So we have installed sensors in the connecting soils, trying to see also the influence of the type of soil into the energy performance, but also sensors on the energy system and pipes, including at the heat pump level. So this is what we have been monitoring for over a year now, having already preliminary results that are showing very positive results, and also very happy students in the rooms that have been rehabilitated this way. So with that, I thank you for your attention, and I'm here to answer any questions that you might have.
Thank you, Julia. Another very interesting presentation. I already have a question while someone else types maybe. My question is, what are things can be the steps in the development of GeoWalls? what can be done? Or what are the next steps? Yeah, this is the question.
Okay, thank you. Thank you for your question. So, of course, we are looking to develop a system that needs to be as efficient as possible. So here we are discussing also about optimization. What we have done in the pilot site for REN+HOMES, for example, when we installed the system, we backfilled with two types of soils and with different configuration of the pipes, trying to better understand how the system behaves and what are the main influencing factors in its energy performance. Because what we are looking for, as I said, it's for structural integrity, but also energy performance. So in terms of energy, our purpose is to harvest as much energy as possible. So one of the idea and next steps in development is to make this system as efficient as possible and change the things that we can change so that we can get the maximum.
Okay, I see. Thank you. Are there any other questions? Maybe there is a new question. Okay. Yeah, I can read it for you. The question is this method co-funded by a European program so that it can be accessible by several citizens of the European Union? Thanks, Caterina, for asking.
Could you please repeat? I did not hear it very well. Sorry.
Yeah. The question is this method co-funded by the European program so that it can be accessible by several citizens of the European Union? I mean, I think that the question is, can this solution be replicated in other countries, for example, in other buildings, in other places?
Yeah, like I said at the beginning, and that was the main purpose why I showed also what types of problems we are targeting with the solution. It's exactly this, the scalability of the solution. And yes, this is the purpose, to be able to implement it anywhere. In concept, the solution and the technology itself can be implemented anywhere, because the technical basis of the solution relies on the fact that through the geowall, what we do is during summer, we inject heat in the wall in connecting with the existing soil. And then in the winter, we harvest that heat that we injected during the summer. So at the end of the day, the secret behind this system, the general secret, I would say, or as a broad explanation, if you wish, is to make sure that we have a balanced system that works properly between seasons. But yes, basically, we don't need any other source. This is the energy source, and it can work anywhere where we have the main condition to have the interaction with the soil.
And if I may just add something to your answer, yes, I would say this can be replicated all over Europe, because this is the purpose of projects such as REN+HOMES, which are indeed funded by the European Union and which have the aim of spreading science within all European countries. So all project results will be open access. So at the end of the project, it will be possible to collect details on the results of each pilot site, of each technology. So yes, Katerina, I confirm that all these solutions are totally replicable. So I hope we both answered your question. And now, if there are no further questions, I would move on to our last REN+HOMES speaker. Thank you again, Julia, for your contribution.
Thank you.
And welcome, Catherine. Please, the floor is yours. Catherine from the Estonian demonstrator.
Hello. I hope you are seeing my screen already. So My name is Katrin, and I'm from MatTech. Just briefly to introduce our company, we are one of the oldest and most experienced prefabricated timber and timber frame house producers in Estonia. We are mostly doing elements and also modular buildings, and the idea of renovation and energy efficiency has been touched from our side before, with also European Union project to use prefabricated wall elements to insulate and therefore have better housing properties for dormitory about 10 years ago. And from there, we have moved on, and now we are aiming to we are developing a product that is a wall element insulation with PV panels on top of them, so that the solar energy can be gathered from the walls, and so it's like a different approach, because most used solution is only the roofs of the buildings to be used to collect solar energy. And so Tallinn demo is a dormitory building that has been built around beginning of 2000s, and then the object of this project is to improve the thermal insulation of the building and utilizing then the surfaces of the walls for solar energy productions. And this is the illustration of the building that we started with. I have to admit, it does not look bad at this point either. It's like quite modern building, but as it went already into the renovation, we could and can use it for our demo site. So how the process starts, just to have an idea what is the existing building like. We contempt and have done point cloud scanning for the building, where the elements are going to be placed, so that we have an accurate understanding of the height of the building, because it can differ from the drawings from that building time, because of the allowed tolerances of building itself. So if we do a point cloud scan, then we can have a most accurate idea of where everything really is in real life. So all the openings and all other important information. And from there, we start to plan. So, and we in the demo, we did it with architects and also with the roofing solar team, who then is responsible for providing the PV solar panels on the top of the walls. This is an example of this first or second version of the placement of the panels. So they marked with gray is the solar panel parts, and marked with black is regular sheet metal for the roof. The placement of the solar panels depends on the height of the panels and also the requirements for the escape roads on that wall. So we couldn't go nearer to the wall, to the doors than marked here. This is then solar roof. It also makes plans the different ways into collecting all the cables that need to be collected and then put into the inverter for the electricity to be harvested and also used. So this is a 3D model of the new planned version of that building, and this here we can see the escape route, and it illustrates why we couldn't go further with the solar panels. The tricky part is that we need to also connect the wooden elements to the walls. So there is there needs to be metal brackets and brackets to install. And also, not only the problem is how to connect, not the problem, but we need to find the solution how to connect. We need to find it. It's also there to find the optimal way to spend as less time on site as possible. So here is then the mark with this reddish color. It's like the wall panel that we are going to put on top of the existing wall, and the existing wall is then this gray concrete wall. And also to collect data to see how these panels are working with the humidity and also with temperatures, different temperatures inside the panels. And inside the existing wall, we with TalTech team, Tallinn Technical University team, have placed inside these elements different sensors to then monitor the wall panel behavior when it's already on the wall. As said, we are taking then into account the moisture and also the temperatures inside the wall. So the idea behind our product is that we kill two flies in one go, so-called. So we have already the solar panels on the elements, and also we can improve the energy and U values of the walls kind of same time and quickly. I need to say that the planning of this kind of method is time consuming. We need to do a lot of planning ahead. We can't start building like when the idea comes. But when we are done with the planning, then that work on site is quite short. So here is some pictures how the different sensors was put inside the elements. So the layers were peeled off. Every specific position for the sensor was like attached, and then all the element was rebuilt in this sense, so that no energy values or nothing will be nothing is going to change in these values. So here is an example from our factory. This is a Matex part that has been done. We have put on the element all the patterns on top of which will be the profit solar elements, also with metal sheets. And here is an example then on the right, the work in progress. All the cables for the roofed solar panels have been put inside this guiding metal line, and then on the left we see the finished product that goes out from the factory. Then the part which a little bit more shinier finish is the part where the solar panels are, and the other is sheet metal, just regular sheet metal. This was the planned vision from the finished product in this on-site. And this is the work in progress as we were putting the elements on their place. So as the work is still ongoing, I can't present you at the moment like the finished pictures, but hopefully by the end of the spring, we have also already this nice pictures from the whole architectural idea of this building with solar panels, and also then we hope that we have our first solar data, also the productivity, and then the chance to see how much it can be used, because they means that all the energy that we are producing from the building will be also used inside the building. So this is thank you from my side, and thank you for your attention.
Thank you, Catherine. Yeah, we're looking forward to seeing the finalized building. So yes, let's see how it goes. So just to be sure that we are sticking to the timing, I would suggest that we collect questions for you, and we ask you the questions at the very end of the webinar. And now I would leave the floor to our last speaker, our guest speaker, Pablo Fernandez from the Circular Project, who is also going to talk about wood panels, right? So yeah, maybe also the questions could be suitable for both of you. Please, Pablo, welcome. And yes, the floor is yours.
Thank you. Good morning, everyone. Good afternoon. I'm going to share my screen firstly and put the presentation mode. I hope all of you can see my presentation. Today, I'm going to talk about some hardware that is, let's say, complementary to the one presented here in REN+HOMES. As Federica said, we are participating in Circular Project, which is quite connected to this one. And I'm going to briefly present two solutions that are related to the main goals of those projects and that have been developed inside our company. Okay, my name is Pablo Fernandez, and I am the Research and Development Manager of Formipresa. Well, to shortly introduce my company, the company I work for, we are a medium-sized precast concrete company based in Catalonia. We have a couple of factories in Catalonia and a commercial office. We have another factory in more or less the center of Spain and a commercial office in France. And our market area is basically the red part of the map you can see in the left-hand side of the screen. From the beginning, we've been mostly dedicated to precast buildings and precast single-family houses. Okay, in general, all kind of buildings, residential buildings or industrial for any kind of use, basically. Okay, but today I'm going to introduce you two new solutions that have been developed within this new approach of making construction sustainable and more efficient. Okay, the first one is already in the market. It was developed inside the Meta Building Labs project, which belongs to the Horizon 2020 program. And it's a new timber concrete bearing wall for newly constructed buildings. In this case, it's not for renovation, but as you will see, it implements a new vision for what we have been doing throughout the years. In this case, the hybrid wall is a new sandwich wall, and the main novelty here is that we have replaced what usually is a concrete bearing panel by a CLT panel. So in this case, we have created an element that has this architectural concrete finishes on the outer part. It has an insulation layer in the middle, and it has a CLT panel in the inner part, which is also the structural part of the panel. I mean, the concrete here is only the finishing. It protects the wall, the timber from the exterior. We have the insulation, and then we have the timber inside. Okay, this kind of wall can be combined with concrete floor slabs, timber floor slabs, etc. It has to be seen as a CLT panel with a higher degree of industrialization, in this case with the insulation and also the finishing attached to the panel from the beginning. Okay, what makes construction faster than the usual way of proceeding with this kind of panels. Okay, well, here I have some pictures because we have developed the full element from the very beginning and also the manufacturing system. Here in the left-hand side of the screen, you can see some picture of how a hybrid wall is produced. We have to put a form to, let's say, to cast concrete, as you can see here, usually white concrete. Then we have a system to support the CLT panel on top of the concrete in its exactly position. And as you can see here, this is a already finished element. And the most, I don't know, fancy point of this element is that you have the concrete outside and the timber inside, and the vision is completely different from one side to another. We have also tested the connection between the two layers, the response of the timber when loaded, when partially loaded by a hollow core slab or something like this. I mean, we have developed everything in the system, and now we are obtaining the certification for the Spanish market. Also, we are about to build our first building, our first real building. We have built two pilots in our premises here in Catalonia, basically offices for the employees of the company. The first one was built almost 3 years ago, and so far we have no pathologies. People is, let's say, good inside. We have comfort, and I think is the aesthetic of the solution is better than the concrete solution. Of course, this solution is applicable to any kind of residential building. It's also replicable all over Europe because, as you know, CLT and concrete are available basically everywhere. So this solution can be replicated basically everywhere in Europe. And also I would like to remark the comparison between this new element that we've invented and the regular concrete sandwich wall. As you can see in the CO2 emissions, this is in phases A1 to A3. The regular concrete sandwich wall is about 80 kilos per square meter of facade, and the hybrid wall is minus 60 kilos. Okay, the difference is huge. And also the thermal resistance of the regular concrete wall with the insulation that we usually put is 2.84, and with this solution with timber, which combining the same insulation plus the insulation that timber adds to the whole wall, we increase the resistance from 2.8 to 3.9, which is quite significant. And as I said, this is we were a concrete precast manufacturer, but we understood the needs of the market and also the needs of our society. That's why we started developing these hybrid elements, because we don't want to give up our business, but we need to adapt it to the new reality. And the other solution, which have been developed within the circular project, are insulated concrete panels for building retrofitting. In this case, in circular project, also with recycled and carbonated gravel and bio-based insulation. I'm going to explain step by step this solution. Also, as I said, it is being developed in the circular project. In this case, we have not reached the market yet. We still have some developments to do, but we are, I think, doing good so far. This solution was developed in the past in Omipresa within the framework of another project. As you can see here, we put a couple of panels in a building in Asturias. The main point of these panels is that they are thin. So concrete is a very pollutant material, so it's very important to use the less as possible. So our idea was to manufacture the thinnest possible concrete panels, allowing us to lift them, to place them, to handle them in general. Also, this is a demountable and 100% recyclable solution. I mean, you can separate insulation from concrete, you can grab concrete and you can recycle the insulation. You can disassembly all the attachments in the facade. They are made of steel, so also you can reuse them, etc. And one of the main things that we want to do in circular is to use carbonated recycled aggregate. I will explain it deeper in the following slide. I'm going to finish the summary of this element. Also, this concrete panel may be combined with any kind of insulation. and in circular, since we are trying to obtain the, let's say, the solution with the lowest possible carbon footprint, we are combining it with a plant-based insulation material made from recycled cardboard and hemp. I have to say that we've seen that organic insulation is not very, let's say, it works badly with fresh concrete, okay? Because fresh concrete is alkaline, the pH of the water is high, and it tends to decrease the performance, either the insulation or the resins, the organic resins that are gluing all those cardboard and hemp fibers together. And as you can see in the picture, we successfully installed one of those panels in a pilot building in Asturias. As you can see, we can make blind panels or panels with opening for buildings with windows, etc. Here is one of the biggest points. We, as a concrete manufacturer, we create, as part of our process, a lot of waste, a lot of pure concrete waste, okay? As you can see in the top left picture, we have like a mountain of debris, basically cuttings from pieces, some waste for all the processes, etc. But basically they are cuttings from hollow core slabs, okay? We generate and a significant number of tons of debris every year. So we decided to do something with this because it is concrete, 50 megapascals concrete, so it can be used for as a recycled aggregate. Okay, so we've developed a process where we take all those debris, we grind it, we classify it, we put it in different batches, and then we put it in the batching plant. Okay, that's the idea. This is recycled aggregate without carbonation. This is only reusing the waste that in the past we were throwing away to a landfill or something similar. You know, we are putting this waste into value and finding, let's say, elements, concrete elements that may accept this gravel. In our case in Spain, the regulation is very restrictive regarding the use of recycled concrete as aggregate for new concrete. So we have to find those elements that accept the use of this kind of aggregate, because, for instance, in pre-stressed concrete, you cannot use recycled aggregate in Spain, okay? Because in other countries you can, but in Spain the regulation is the one that we have, and we cannot change it, at least at this moment. That we are using it only in particular elements and up to 20% substitution. I have not talked about sand, recycled sand, only gravel, because recycled sand is forbidden in Spain, so we are not focusing on it. And the other big point of these panels is carbonation. As you can see here in the left side of the picture, we are putting our aggregates in a carbonation chamber. The point here is that concrete has calcium, and every mineral that has calcium has the potential to capture CO2, okay? You cannot carbonate plastic, you cannot carbonate a brick, you cannot carbonate timber, you can carbonate elements with calcium, okay? And concrete has calcium. Here in this picture with this purple color is because when you have the crushed concrete without any carbonation, you spray a reactive on top of it, and when it has calcium, it reacts and becomes purple, okay? And after putting the aggregates in a carbonation chamber, you apply again that reactive, and all the calcium has been combined with the CO2 to create limestone, and calcium itself has disappeared, okay? And that's basically the process of carbonation. there is a component inside the concrete called calcium hydroxide that has the potential to absorb CO2 and become limestone and drop in some water, okay? And it is a natural process. We don't need high temperatures, we don't need high pressure. We can do it without the using of any energy. So we are capturing CO2 without emitting CO2. That's a very important point. We are taking this laboratory work to the industrial scale. Now we are doing exactly that in Circular project. We are in that phase. Hopefully everything will be as expected. And all the laboratory results have been quite good. On the left-hand side of the screen, you can see the first test in the compatibility test between the insulation and the concrete slabs. As I said, as you can see here in the top right picture, after putting the slab and the insulation inside the oven with high temperature and high humidity, what is what we do to cure concrete, the organic insulation suffered. And it's like, I don't know how to say, but like the resin, the fibers are loose. And we saw that the compatibility between fresh concrete and organic insulation is not very good, and we will probably add the insulation after the curing process of concrete. Otherwise, we cannot guarantee the performance of the insulation. Okay. And well, in Circular, we have this building, and this is our new challenge. This is the building we have to cover with these new panels. We are going to start with this part over here. This part has a pathology. It is covered by fibrous cement planks, and they are falling down. They were badly placed and they have this pathology. So we are going to start in this area of the building. And if everything goes well, we will maybe project to cover the rest of the building. Okay, but in principle, within the Circular project, we will only cover this part of the building. We've performed all the energetic studies, etc. We are not in charge of that part of the project, but we've done all the assessment, etc. And the idea is that these panels and their attachment system to any facade to be replicable all over Europe. I mean, we did in Asturias, we are going to do it again here in Barcelona, and the system is basically valid for any kind of residential building. It depends also on the original structure of the building. Of course, we have to do a preliminary study to see that the structure will resist the new loads, that we can attach the panel to it, etc. But this is the main idea. And that's all from my side. I would like to thank Federica and Anna for inviting me to this webinar. And if you have any question, please do not hesitate to contact me now or after the webinar via email.
Thank you, Pablo. Another very interesting presentation, and it's always very important to collaborate within similar projects. So thanks for joining our webinar, and also for the example of recycling, because recycling is in fact a way to optimize resources. And so, yeah, let's hope that there will be harmonization of laws or norms also in the time. I can see that there is a question in the chat. So the question is, thank you for sharing this approach. I would be interested to understand the long-term performance of plant-based insulation, specifically regarding maintenance requirements and expected service life. Could you also confirm whether this system has an ETA, European Technical Assessment,
Yeah, regarding the insulation, we are not the ones that have developed it. Okay, it was developed by the Technical University of Catalonia. But what we've seen so far is that organic insulation should be placed in the interior of the buildings because it doesn't resist water. Okay, the contact with water will decrease the performance of the insulation, and in the end, all the resin, the organic resin that is putting all the fibers and the cardboard together will vanish. Okay, so durability is okay, but only inside a building. I mean, as part of, I don't know, behind one of those gypsum boards or whatever, but not for the exterior part of a facade, because we found some difficulties. We have to protect it very well. I mean, we have to take measures that usually you don't have to take with a commercial or, let's say, not organic insulation. The expected lifetime, I don't exactly know. The idea is to create a solution for at least 50 years, but as part of circular project, the UPC is the University of Catalonia is testing the service life of this insulation, because, as I said, if it is exposed to the weather, it is going to be the expected lifetime will be very short. Regarding maintenance, concrete panels do not need any maintenance, but if you have to protect the insulation behind, you have to seal all the joints, and you have to check those joints every 5 years, 10 years at maximum if you use a very good sealant. But that's the reality that we are seeing. And no, so far we don't have still an ETA for the concrete, the refurbishment concrete panels. We are still in the development phase. If everything goes as expected, the last step of the development will be obtaining the ETA.
Okay, great. Thanks, Pablo, and thanks also for the question. Very interesting. So,
Okay.
time is almost over. So, yeah, before closing the webinar, just I would say I could just give a couple of takeaways from this webinar. So first of all, I would say that we had various examples of hardware that respond to different needs of energy optimization. So different hardwares can help responding to this need in different ways. And also that's possible to mix and match different solutions and different technologies, and also hardware with software. And in fact, in next webinar we'll delve into the software solutions. And yes, I would also say that it's interesting to see that all these technologies can be applied to different types of buildings and to all European countries actually. And today we saw that they are already being applied in many different countries. So scalability and replicability are key aspects of these solutions. Yeah, I would say maybe this could be a summary of this webinar. I want to thank very much once again all the speakers that contributed to this webinar, all REN+HOMES partners, and of course also Pablo from Circular for this interesting synergy that we created today. And yes, once again, you will find the recording of this webinar on our social media channels, which you can see here in this slide on the right, REN+HOMES. Yes, once again, thanks also to the attendees, and see you in next webinar. Enjoy the week. and enjoy the day.